Hey guys, it's Rose Company, and today we're going to teach you how to prove music. Okay, so today we're going to prove that pi r squared is equal to the area of a circle. So we're going to draw a square, and within the square we're going to inscribe a circle. We're going to label the remaining triangles as A, and one side of square as S. Yes. And then the other one we're going to draw a hexagon. We're going to do the same thing. We're going to label the triangles as A's. And the side as S. Okay, so let the diameter be S, and then the radius be S over 2. And using the first diagram as the basis, let 4A be equal to S squared minus pi times S over 2, which is the radius quantity squared. So back to the second diagram, we're going to draw the hexagon again. And now we're going to label the different endpoints as A. Different endpoints as A, B, C, D, E, F, and G. Then from there on, we're going to put a dot in the center. And from these different endpoints, we're going to relocate it towards the center. We're going to label the radius as X and theta within F and E. So let R be equal to X. If that is true, then segment AB is equal to segment BC is equal to segment CD is equal to segment DE, also equal to EF, FG, and segment GA. Presumably, we all know that the circle has 360 degrees all around. Given in the illustration, we can say that theta is equal to 360 over 6, which is also equal to 60 degrees. If the value of theta is true, then angle AXB is equal to angle BXC is equal to angle CXD which is also equal to angle DXE, which is also equal to angle EXF, angle FXG, and angle GXA. Now that we've got that lined up, let us presume our example within triangle BXD. We're going to identify its properties using the 30, 60, 90 degree laws in triangles. we're going to use a part of the illustration to draw a triangle BXD. Label them as B, C, D, and X at the end. So from X to C, we're going to draw a separated dotted line. And then from X to the midpoint of B and C, we're going to also draw a separated dotted line and label the point as B sub 1. Let us recall the 30, 60, 90 degree property of triangle. We're going to draw a right triangle with the right angle, and we're going to assign its values 1, 2, and square root of 3. Using the illustration given in triangle BXD, we're going to re-illustrate. We're going to cut this in half, and then the value within its hypotenuse will be S. The angles at its base will be S over 2, and the height of the triangle will be square root of 3 times S over 2, which is the base for both triangles. Since we already proven the fact that the area of the triangle will be S over 2 times square root of 3, therefore the area of triangle BXC is equal to 1/2 times quantity square root of 3 S squared over 2, which is also equivalent to square root of 3 S squared over 4. That's one side. Since we have 6 sides, we're going to multiply this value by 6. Therefore, the area of hexagon, will be 6 times square root of 3. 6 times square root of 3 S squared over 4, which will be equal to 6 square root of 3 S squared over 4. Simplify that. It will result to 3 square root of 3 S squared over 2, which is now the area of the hexagon. As N, it represents sides of a polygon. Polygon approaches infinity. Its area and perimeter goes nearer to pi r squared. Therefore, by the laws of mathematical induction and previous laws we just used, pi r squared is congruent to pi r squared for the area of a circle. Okay na.